Hey, hi everyone, welcome back to my YouTube channel. This is Omsi Reddy. Today in this video, I am going to explain about the Seaborn library. It is a third part of the data visualization with Python. In this series, there is 4 videos. First one, I have explained about the data visualization, and second one with the graphs of MATLAB, and the third one I am starting with the Seaborn library. Okay, let's move into the video. At first, what is meant by Seaborn? Seaborn is a Python data visualization library based on MATLAB. It provides a high-level interface for drawing the attractive and informative statistics graphs. It is based on mostly it is based on the MATLAB library, but when you compare with MATLAB, we can draw very high-level attractive graphs by using the Seaborn. Okay. For installation of Seaborn, just you want to type pip install Seaborn. It automatically you can install this. If you want to go for Anaconda, you can just type pip install Anaconda Seaborn. Okay. And whereas a version, when you we want to know which type of version we are using this package, we can simply dot sns dot why I'm using sns means in importing of libraries, I have used import Seaborn as SNS, whereas Seaborn is overall this Seaborn is considered as SNS. So that for that case, I am use SNS dot version underscore version. Yeah, here SNS dot underscore version underscore. It will execute this 0.111.0. It is a version of Seaborn which we are using. Okay. At this first we want to know what are the statistical relationships in the Seaborn, how we can draw the graphs like that. So for that thing, visualization statistical relationship. What are the statistical relationship? At first, what is mean by visualization statistical relationship? Statistical analysis is a process of understanding how the variables in a data set related to each other and how those relationships depend upon other variables. Visualization can be a core component of this process because when data are visualized properly, the human visual system can easily return and patterns that indicate their relationship. It means it is statistical how that it means that how the variables in the data set is each related each other. How much the relationships depend upon the each variables. It is can human easily identify the visualization by seeing the eyes. It is easy to see the relationship. Okay, and first one of this is plotting with categorical data. There is a different in our data set. There is a contain different types. We have contain audio clips, video clip, images clip, images data sets, numerical data sets, and categorical data sets. So many types of data sets. For that case, how we can plot the data graphs or anything with for categorical data set. Okay, let's move into that. In a relationship plot tutorial, we have seen how to differ the visual relation representation to show the relationship between the multiple variables in a data set. In example, we focus on the case of you can just buy over this. These are all over thing I have copied from the Google. You can check over it. Okay, what is the uses of by using of Seaborn? In Seaborn, there are several different ways to visualize a relationship involved categorical data. There is a different types of relationship in the different types of ways we can visualize the relationships of categorical data in the Seaborn. For some, there is either a scatter plot, line plot, or making some high level scatter plot, or some other relationship plot or related plot. So many things we can use to different types of plots are there to visualize the categorical data. It helps to think of a different categorical data kinds as it belongs to the 3 different families. Okay, whereas a kinds it is a kinds is one of the parameter in the kind is one of the parameter in the Seaborn. You can easily change that kind value. Then it have 3 different families. For categorical data, you have take 3 different families. From that families, you want to choose one of the graph and you can place over in the kind. I will show you how to place that kind value also. Okay, let's move into what are the different types of families in the categorical data. At first, categorical scatter plot. Categorical scatter plot, it is a one first family. This family is contain of strip plot and span plot. These two are the strip plot and span plot are the two types of category scatter plot. When we can replace the by default, it kind is located at the strip. If you want to change this kind value, kind is equals to if you want to select this scan plot, strip plot, if you keep the kind is equals to strip, it is a necessary for we want to visualize the data in different graphs. Kind is the main thing. Okay, and the second family is categorical distribution plots. In categorical distribution plots, it contains of box plot, volume plot, box and plot. These are the three types contained in the second distribution plots. If you want to distribute the data by using these three plots, so we can distribute the data by using box plot, volume plot, and box and plot. Just you want to make the name of the graph in the kind, it will automatically know that we are giving that type of graph. And the last one is categorically estimated plots. What is estimated means estimated values. For that case, we are using that point plot, bar plot, count plot. These are the estimated plots. Okay, if you want to use this type of plots, you can simply write the kind value. Kind is equals to, if you want to find the point plot, simply we can give the point. If you want to give the bar plot, simply we can give kind is equals to bar. Count plot, simply give the count. These are the families which are in these categorical features. If you want draw a graphs in different plots, just make sure you want to keep the kind value. Kind is equals to sum. Which type of graph you want to use, keep that graph name. It automatically knows that you are doing this type of graphs. Okay, and the next topic is relating values with the scatter plot. We have seen that, but now how the scatter we want to relating the variables, each variables with the scatter plot. By using scatter plot, we can relate it to each one. For that case, I am using this tips. Tips is one of the inbuilt data set located in Cboard. Okay, for that I am taking this tip dataset, whereas tips is also sns.load dataset tips, and this is the head of the tips. There is a total bill, tip, say smoker, day, time, size. This is dataset columns which has contained in the tips. Okay, I'm going to draw a graph for relative graph variables, in which for that case sns.real plot. Real plot means relating relating. Real plot means relate. It will show the relation between the two variables. For that case, I am passing the x is equals to total bill and y is equals to tip, and data is equals to tips, whereas the data I have stored this tips. Okay, let's run this code, and it's perfectly executed. So this is a scatter plot between the total bill and the tips. This is where the points are lying between 50 to 10. Here the where the 250, and so many plots are so many data is formed between this plot. We can easily find highest plot, highest data is located at 50 10, and the least is located at nearly 2 to 1, I think so, 2 to or 0.1. It can say that, we can say that 2 to 0.1 least and highest thing. And I'm going to import one other feature into that real plot, so that I am using sns.real plot. I am passing x5, but we want to show another column or another feature. For that case, use is equals to smoker. I am given that use is equals to smoker. We can see here here the blue lines are blue, which we have given. Blue is equals to smokers, and orange is equals to no smokers. This is the thing. We can easily identify where the highest smokers and where is the lowest smokers are contained. And then now I'm going to give the styles styles of smokers. We can easily find, if we want, if there is no smokers, we can simply, there is no smokers, we can say that overall all this thing, and I am using this time by time, and smokers by using the time only I have done. If there is cross marks, it is a dinner time. Where is the round dot, it is a lunch time, it is a lunch time, and it is a dinner time. We can simply write this, we can simply draw these graphs by using, just you want, if you want to, what are the parameters in this graph, just shift plus tab, we can know that what are the things I have there. X, y, whose, size, style, data, row, column, these are the parameters of this rail plot. We have also description about the parameters. You can simply read it and know about this plot. Okay, if you want to more about information about these plots, just go to the cbond documentation. You can easily find, I have all these things I have copied from there and explain for you that. Okay, and same like that I am taking another data set, farming, for fMRI. It is one of the data set contained in this cbond inbuilt only. Okay, for that I am reading this data set, and the head is, these are the subject, time point, events, region, signal. These are the columns of this data set. For that I am passing this relationship, I am finding the relation. So SNS dot really plot x is equals to time. What is the relation between time and signal? And kind equals to line. I said that kind is the main important thing. Kind decide that which type of graph we are doing. For that I am given a kind is equals to line. It shows the line graph. See, it shows the line graph. Okay, it shows the line graph like this. And same I have given this kind is equals to, it also shows the line graphs, and where kind is equals to even line. For here I am using here the line, we are using both x and y, but here we are using for events also, we are adding events also. For event there is a orange line, it is orange line for event. And for time, signal and time, there is a variable. Okay, these are all the things about, if you want to know more about this, just you have go to the documentation, you can get everything. Okay, next thing is we are going to discuss about visualizing distribution of data. What is visualizing distribution of data? It is a distribution of data by using a distribution plots, or distributing some data from each and every thing. Further they can find the outliers, and we can clearly understand where the data is distributed, from which range of the data is distributed. This is a statement of this distribution of this. An early step in other effect of visualizers or a model data should be to understand how the variables are distributed. Techniques for the distribution visualization can provide quick answers to many important questions. What the range do the observation cover? What is their central tendency? Are they heavily skewed in one direction? Is there any equivalent or binary data? Are there significant outliers? Do these answers of these questions vary? This subsets defined by the other variables. These are all questions we can easily find by using this distribution plot. For that case, I am using this penguins data set. It is also inbuilt data set. You can just go to the load the data sets and you can find it. And I am giving the this plot. This plot means distribution plot of penguin, and in that I am using one of the thing. Just see what are the things there in the columns in the penguin. These are the columns. Dot. Just keep the head. Top 5 rows. These are the columns in the features in the penguin dataset. For that, we have take distributed SNS dot displot penguins. I have take x is equals to this per length minimum. If I take this build depth length, we can replace over here and we can see that graph. Yeah, this is a graph distribution block graph of build depth okay. We can say like this only. If you want to see for all these types of lines, just copy this and paste over here, and I am copying this. This is a distribution plot, and I am also copying this. Billion. Yeah, perfectly. The data is distributed. Its range is 9. There is billion. The minimum is range is 9. From 9 to it's a from 9 to highest range is 60. Okay, this is a we can simply know that there is a 192 between 190 to 200. There is a lot 190 to 195. There is a lot of paper length is there in penguins. Simply we can understand like this the data sets. And next topic is choosing the bin size. Bin size is most important thing in the visualization parts, because by using the bins only we can correctly predict the visualization part. What is the uses of bin? The size of the bins is important parameter, and use the wrong bin size we can, if use the wrong bin size by the important features of the data, or by creating up right appropriate features out of the random bins. If you give the wrong bins, it is completely destroy all the graphs. Please make sure you want to see which type of bin is we are using, or how the bin is using. So it is important in bins. Okay, for that I'm giving this plot. SNS dot this plot penguins x is equals to paper length, and width is equals to 3. Bin width, it is a bin width, size of bin width, it is a size of bin width. This is the size of bin width. Okay, we can consume this size of bin width, and if we give this for change, I have changed this by 2. What is the bin width? Yeah, see, this is the bin width. It's located too small. If you give this 6, what the difference? See, it is has increased the size of bin width. So when you give the bin width, it will decide how much the length of the graph will be decided. And next one I am going to give the same. I am uploading the data set tips. I have recently uploaded this data set, and I am plotting the sizes of these tips. So this is the sizes of the tips, and this plot and sizes I'm by giving randomly these sizes 1 2 3. This is the bin sizes, starts from 1 to ends from 7. Then the sizes are distributed between the 1 and 7 like this. See, you have, and below there is a graph. We can simply it is formed like this. Okay, when you give this range of bins also. Okay, now conditions on other variables. Conditioning on other. Once you have understand the distribution of variables, the next step is often to ask whether the feature of that distribution differ across other variables or not. It means if you have understand about the distribution variable, how the distribution plots works, then the next step is you want to, and how the distribution offer the across the variables. You want to know how the distribution across the variables. Okay, for that case I am using the same data set penguins. In that penguins I am using the use of species. There is let's show the penguins. This is a species. There is a lot of species in that. Okay, we simply we can see how many species. There is a 3 species in this. Overall they are covering up to, there is a highest of this species, blue line species, and low of orange line, and medium of this green line species. Okay, if you this is a thing, this is this graph is measured each other species. We can't find easily. For that case, we can use this element is equals to steps. We can find is how the step overall the steps of the species covered, like this. If the blue species covered with 172 to, this is a blue cover up to end at 220 215 right now. Yeah, 215. Like this we can find this PCS length. We can simply find how the PCS is separated steply. If you want to change anything, if you want to know what are the parameters in this plot, we can see this. These are the parameters of this plot, and we have no here the description also given. You can read this description and understand more about this plot. You can easily find how this plot and just learn. Don't worry about the code. Just learn which type of plot is best to visualize the data. It is only you want to think. Overall the code you have get in the description. You have get in Google. Okay, just think how which code is you which graph is best to do visualize. How can this graph visualize this data set? If you have used the different graphs, we can easily find the what the relationship between the data set in the variables and how the variables are related to each other. These are the things we can easily know about that. And the last one is we in penguins there is a two types of penguins. One is female and male. For that also I have printed a graphs. This is sns dot plot penguins is a data set, and x is equals to flipper length minimum, and colon is equals to which column I am going taken, which column I am taking, 6 column is taken. So we have put two types of graphs. One is for male and another one is female. Its range starts from 178 to 231, whereas the female's range starts from 172 to 225. This is the range of the data set. How the penguins male and female are the contained in this column data set. Okay, simply we can analyze these types of this, like we can see that ranges of this data set. And the next one is kernel density estimator. Kernel density estimator is important because density of we can find how much the data is plotted, how density it works on bins. Mostly histograms aims to approximate the underlayering probability distribution function that generate the data by the binning and counting the observation. Kernel density estimator KDE represent a different solution to the same problem. Rather than using the discrete bins, a kernel plot smoothen the observation with a Gaussian kernel, producing a continuous density estimators. It means we can. It is mainly approximately. It is a probability density functions, like it can generate if we give the discontinued. Also, it can be changed into the continuous types. Like for that, I am using this. Penguins data sets, and for that penguin data sets I'm just passing this flipper length and kind is equals to KDD. It means KDD means kind is very important. Kernel density estimator KDD. For this case I'm using kernel text. We can also change the bandwidth like this, adjust the bandwidth adjustment. We can before using bandwidth we have get this type of graph like mountain. After applying the bandwidth 0.025 0.25 we have get the graph like this. There is a lot of difference. If you give this 15, there is it can change the graph length adjustment. It can change the width of the graph. If you give 0.50, simply we can see this. It's clear. There is no struggles of this graph. So a better thing, which type of graph is best to visualize. Choose your thing and visualize that type of graphs. Okay, and the next one is other variables. For the other variables, I'm giving the species. I'm plotting the kernel density estimator for species type. So in same data, some data type and some data set I am taken, and the x is equals to if I change this into the, just wait, I will change the x value. We have a penguin has a lot of columns. I have taken this bill length and present the graph. Yes, S3 center or not. Yeah, perfect. Look at here. By using x is equals to bill length for species, we have applied the kind is equals to kernel density estimator. This is the graph of kernel density estimator. The species is we can easily find like this. Okay. If you want to choose a multi-task, if we, here we have seen the gaps between these boundaries. We want to complete this filling it to these boundaries. We want to use the multiple is equals to stock. We have, if we put the multiple is equals to stock, it will completely close the boundaries. It will draw the graph where the graph is overall the diagram is located. Simple, we can see here. You should understand this. You can clearly understand about this thing. Okay, I think so you have understand how the graph is totally plotted. It will completely cover this graphs. There is a graph between, this is a simple line. We have seen this simple line, but here the closed the, it has closed the whole line boundaries. Okay, and the next one is we are going to discuss about plotting joint and marginal distribution. This is another type of distribution. I am using joint, probably joint plot. It is a jointing of two types of plots. Okay, jointing. I am taking the data set penguins and I am passing the x is equals to bill length and y is equals to bill depth. This is the plot of between the joint plot of x and y. This is a these types of plot, and this is a width of bill width this is the length of bill width Okay, this is how the data is plotted in scatter plot. We can jointly distribute it, where the distribution plots and histograms and scatter both are jointly distributed. This means joint plot. Giant grid also one type of plot. It is used it is a convenient interface of giant class where often the flexible and used directly. It is a flexible graph. We can simply see the flexibility of the how the data is plotted. It is a dotted, and it is how the where the highest we can see here the highest data set is present. It is the lowest data set is present. It is also print the output of two graphs. Two plots are two plots like giant. It is a block plot and it is one type of scatter plot. You can see here, and there is a high data sets, whereas a light blue it is a low data sets. We can find that where the highest and lowest things are presented, where the how the maximum plot data set are how the data set is maximum data set is covered, where the data set is covered, where the less data set is ahead. We can simply know about this by using the joint grid. Okay, and the next graph is, just wait, I will see how much. Next we are going to discuss about plotting many distributions. Plotting many distributions means we can plot the different distribution plots. That's for that case we are using pair plots. Pair plot function is offered similarly bending of joint and marginal distribution rather than the focusing on the single relationship. However, the pair plots is used small multiple approaches to visualize the univariate distributions of all variables in a data set along with all other pairwise relationships. It is pair plot is very important because it is only used for less small multiple approaches. It is a less data set. If you use a huge number of data set, we can't easily find this data. We can easily visualize the data. For this penguins, I think so. Yeah, I have sns.pair plot. I am passing the data set penguins. This is each and every relationship. What is the relationship between this? This is a relationship bill and bill body mass g. This is a relationship bill depth and body mass g. This is a relationship, and filter flipper length to body mass. This is this graph shows this relation between each and every feature, 1 to 1, 1 to 1, 1 to 1. It can be show the each and every feature of this data set, each and in a data set columns. So it is a very important data set, but we can't use for huge amount of data sets because we can't easily find that huge amount of data set graphs visualization. So it is used for small data sets, like it contain 4 to 5 columns or the minimum 100, like this example I am saying about the example. It is it will use for low, a small or the minimum data set for that pair plots. And these are all things are up to now. We have seen from today video, we have seen about what is C-bond, what is the visualizations part of the C-bond, how to install C-bond versions, and relay plot, and so we have to taken 2 data sets from the inbuilt of C-bonds and displots and different how we want to I have shown you how to draw a print plots for different columns in data sets for distribution plots and different type of plants. And we have taken the kind as here we have taken the kind as kernel density estimators and different types of we have seen here. So many things I have show you, I have explained you today in this video. Okay, now and tomorrow it is a third and tomorrow we are going to discuss about the remaining plots and what are the and I am also tell about data visualization jobs, where you want to find out how much salary can data visualization get, and like this I in the last video I will explain. Today in the, this video is up to now we have completed. There is some more plots and graphs is there. I will explain that graphs and plots in the next video. That is the last video in this series. Okay, make sure you want to learn everything about the data visualization parts. Yeah, there is no need of any Python programming languages, Python knowledge. Basically, if you don't have any basics of Python knowledge, don't worry, it is you can easily understand about that. Okay, I hope you are all understand about this C1 library. Okay, make sure you want to subscribe, share, like to our YouTube channel. If you want to learn more about the data science or web development, full stack development, Android development, any technologies for free and with easy content, just follow our YouTube channel. We are publishing so much content. We are teaching so much best content. Okay, I hope you are understand. Okay friends, bye, take care.